Jump scare. Guys, it's Geometry Dash. Guys, I'm playing Geometry Dash. Kind of. I'm not really playing Geometry Dash. I'm not really playing Geometry Dash at all, actually. I mean, I'm playing Geometry Dash. But this is gonna be absolutely nothing like Geometry Dash. Can I get the link? Can I get the link, please? Yes, thank you. Thank you, YouTube. Yes, so this is gonna be quite funny, I think. I'm also trying not to use my right hand today, but that's fine, because this is fine. Hi, Casey. I think I've talked about this level. I'm gonna go share this in a different server as well. BRB dog. All right. This is gonna be something, I think. Oh, thank you for telling me Infinithreat is live in my notifications. I wasn't aware of that. Okay, I want to let like a couple people join. I want to give time for people to join if they really want to. But this is gonna be kind of just a me thing. I just wanted to stream it because I think it's really funny. I don't know how long this is gonna take me, and I might want to figure out music at some point, which I haven't done. So, I don't know. We'll get there when we get there, I guess. Maybe I'll just like pull up my playlist, but I'll think about which songs are like actually fine and which ones aren't. I'm also eating dinner right now. No, I actually think the music in this level is gonna freaking like drive me insane because it's not music. And I could just listen to my own playlist off stream, but then you guys don't get to hear anything. And then it's like, well, that's evil. Although to be fair, like just playing this, I mean, I'll get into the level. SFX Wind 01, like you can see why it's cooked. You can see why it's cooked. Yes, this is what I want to listen to. This is what I want to listen to for however long it takes me to do this. Okay. So this is the level, by the way. This is the full level. You just get to see this. It's the contraption. This is the contraption. And it looks entirely incomprehensible. Which button? Welcome back. I'm assuming you're gonna have to catch up. So, the good thing is, I forget which one is. Oh, that's the run. Okay. Okay, we should stop that. Yeah, that's how you run it. Right, the good thing is, the evil doohickey that destroys your hand. I'm just not using my hand. It's fine. We have documentation. It's okay. We're gonna read through the documentation, of this Geometry Dash level. Okay. It's designed to answer all of your burning questions, like, what the hell is going on? And what am I doing? They don't like calling it a computer, even though I'm pretty sure this thing's freaking, like, nearly Turing complete. I think it could run Doom. I think it has the space to run Doom. It's a computation machine emulator. Sure. And yeah, it uses ternary. That's why it's DETERNARY. And here's a diagram. So we got quite a bit going on. Testing system, input, output, bunch of like registers that are kind of just there for show, I'm pretty sure, except for the instruction register. And then we got the memory and the accumulator. So that's all good. That's all fine and dandy. The ALU, so that's the accumulator. Yeah, the ALU does the math. Hope your hand will be okay. It should be fine. I just gotta not kill it, you know? The ALU does the math and then does sets the flags when it does the math. So if it's 0, it has a certain thing. If it's not, if it's above 0, then it has a different thing, right? So this is just 0 or not. Do you like yogurt? It's alright. I mean, I'm not like a yogurt connoisseur or anything, but second indicator will either show if there's overflow or underflow, or if it's just fine. And then, yeah, there's certain, it's just telling you, like, negative numbers don't exist, it's just underflow, whatever. I don't have to worry about 3's complement. Right. And now we have the instructions. So this is what, so when you run this, right, we'll just do, I'm out of testing mode. When you run it, it does this. And it's reading every single line of the memory one by one, and it's interpreting it. Oh, you can't see it, sorry. Sorry, let me turn this off real quick. Yeah. You run it, it's doing that. I can stop it. But, it's basically reading every line of the memory. Ah, god dang it, I forgot I did that. Sorry, let me change that real quick. Back at the start. Okay, we're good now. Yeah, it's reading every line of the memory, and it's doing a different instruction depending on this table. And this is basically, this is like pretty much just assembly is what this is. There's quite a few instructions. But it's like fine, right? And then, so what's the goal here, right? This is a Geometry Dash level. There's something I have to be beating, right? Or something I have to accomplish. Well, basically, there's 5 tests. There's 5 different tasks I gotta do, one by one, via code. And it'll check that it works the first 4 times. And then after making sure the code works 4 times, it'll randomly swap 2 of the instructions, and then I have to figure out which 2 got swapped and fix my code, which is great. And yeah, that's basically it. I think that's a good rundown. I think I can just get into it now. I think I've explained about as well as I could, and I'm gonna try and explain my thought process this entire time, right? Just so that, like, hopefully it makes a bit of sense. Alright, task 0 is the maximum of 2. So we have 2 numbers. I have to output whichever one is bigger. And that's it, right? Just, you get 2 numbers, output whichever one's bigger. So, I'm pretty sure that, yeah, there's just a comparison. Right, taking inputs is here. It puts it into the accumulator. I can just put that in some memory value, take the second input, and then I can just compare them, right? And if okay, so it's a subtraction. So that would mean if it's less, then it would be underflow. Otherwise, it would do nothing. I wonder what this looks like behind the scenes. That's a great question. So, okay, we can start off really easy, right? Because it is pretty easy to start off with. So this is where I change the instructions. So now it's oh wait, you can't see it. I'm going to put this. I'm gonna put this in the corner. So. Oh, that's like unreadable. I'll just hide it for now. Just know that's what I'm looking at a lot. I can't really, like... This stream is gonna be weird. Okay, so input, that's input. Now, what I can do is I can go to the next instruction, and then I can set some memory value to this, to whatever I've just gotten as an input. So we can pick probably just like the last bit of memory down there. So I'll go until I see the S. Yep. That just makes it easier for me because then I can see it, but then it's also like far away from any of my code. So we set it, then we take another input, and then we just compare them, right? I mean, it's simple as that. Let me read how comparison actually works. Right. So it uses the address. So I can just put in the address, and it's fine. You may have super sped past the yogurt answer. I just said it was alright. Like, yogurt's alright, but it's not like, I don't know, it's whatever for me. Okay, comparison looks like this. This is compare. So, if the number in the accumulator is greater, if nothing happened, then we just want to output, right? But if it's less than, then we want to do something else. We just put the other number there, obviously. So what we're gonna do is we're gonna jump if there's underflow. And we'll figure out where we're jumping. Actually, we should just be jumping 2 instructions from here. So look for this. Yep. And if not, we just output, right? I mean, if there's no underflow, everything's good, so we can just output. Hello? It's not letting me... Okay. Weird. Output is just 2. There we go. So, output. Otherwise, we need to load. I'm using a lot of different instructions here. And we just load that bottom value. And then we can output. Which, I mean, I'll just write output again. Wait, no, wait, I don't have a halt instruction anywhere. Okay. We're gonna go back here, and we're gonna change this to halt. This goes to the next instruction over. Now we do the load from the bottom address. And then we can do a jump. Okay, I have to show it every time I'm freaking looking for whatever reason. It doesn't update otherwise. Normal jump 15. And this should just go... What does it look like? Oh, it's the 2 lines. It's like that. And this should go straight to the output. Like that. So this should work. Hopefully. My dog sent me to 3rd place. Oh, skill issue. How are you outside of my... I'm fine outside of my hand, by the way. I saw that earlier. I forgot to mention anything. So this should just work. I'm not sure if it will. So it's pausing because it's looking for an input. We'll do 10, I guess. Now it's looking for a different input. Let's do 5, I guess. And it output 10! There we go! Okay. Isn't that awesome? The contraption! Okay, so now we'll try it again, but we'll input 5 first. And then we'll slap in 10. Okay, and now it output 5, which is not what we were looking for. So I need to figure out why that happened. This looks incomprehensible. Well, yeah, it looks incomprehensible, and that's why you gotta. It's the explanation, you know. Okay, I need to watch this carefully, I think. So it shouldn't underflow, I believe. Oh wait, I'm stupid. Oh, I'm stupid, aren't I? Okay, where's the subtraction? Or where's the comparison? Okay, it's really early on. I realized, so I'm comparing here, to the top address, which is a very big number, right? That's like 27 squared or something. So obviously, the first number is just gonna be... Oh, it might be outputting the wrong number. No, it's outputting the first number. Yeah, that's right. Okay. Yeah, this shouldn't be comparing with that number. It should be comparing with this bottom number. And that's why it's wrong. So we're gonna output 5. We'll input 5 first. And then we'll input 10. And it outputs 10, which is what we'd like to see. So that time it didn't jump, right? because 10 was inputted second. So this time, oh wait, whoops, I did it in the wrong order. Whatever, we'll put in 3. So this time it underflows, so it outputs 5. So I think we're good. I think we're good to actually do the testing. Let me just make sure to actually run it from the start. The skill is not within my current wheelhouse. It's not about the actual looking at what's going on here, and it's more about understanding the actual instructions that are going on. It's just that everything, like, you have to think through it yourself to actually, like, really understand it, because, I mean, that's why it's easy for me, right? Because I know exactly what I'm doing. But you, like, I have to explain to you what I'm doing, and it's just harder compared to just, like, thinking it through and then being like, oh, okay. I can try and kind of say, like, oh, I don't have a pointer. It doesn't let my cursor exist. Oh, that's what I have that set to right now? That's really funny. Okay, this is my pointer. This problem solving isn't within it. Fair enough. But yeah, what's happening here is I'm taking an input, I'm storing it down here. I'm taking the second input, I'm comparing them, and then this one's basically just saying if the first one was bigger, go down here and put it back in the thing and then output it. But if it wasn't bigger, then just output immediately. And that's all that's going on. Please work. So now it's testing it. Now it's just giving me random numbers, right? It's just inputting random numbers and checking if the output is correct. And it's worked twice so far. 3 times. So that's a good sign. If it's worked 3 times, surely it'll work every time. Okay, now we're on the final test. Something in my code has been switched up. So I have to... It's not the input. It's not the storage. Did it just halt? Was that a halt? Or was that a... Okay. How do I set flags? How do I set flags? Is that a thing I can do? That's interesting. It just kind of ended there. No, that means it has to be a halt. So halt and my my jump commands have been swapped. So what I need to do is I need to change this to halt. And then I need to go down here and change this to the other symbol, which was this one. And now I believe it should run properly. I should have tested it. I should have tested it. I don't know why I just... Yeah. Oh, wait. No, that's good. That's good. I did it. I did it. I don't know why I did that without testing. That was really scary. No, but it's a different number now. That means it's fine. That was really stupid. No, it's fine. Okay. I mean, I had the logic. The logic was all there. Alright. Let's look at what the next one is square root. So this is yeah, it gives me a number between 0 and 255. So that's less than 16 squared. And it'll give me, and I have to find the square root floored to an integer. So the easiest way, I've done here and task 1 before. The way I think of doing this is basically doing a for loop, where or it's more of a while loop. I check every number, so I start with 1. Oh, actually, 0 is included, so I start with 0, right? Actually, no, I would do 1. So I start with 1, right? I go, is this number squared? Is 1 squared greater than my number? If it is, then I subtract 1, right? Because 1 squared... Basically, I'm trying to overshoot, right? So I overshoot, then I subtract 1. But if 1 is less, that means the square root is going to be greater than 1. So then I check 2. If 2 squared is less, I check 3, and so on. So for example, if you have like 63, right? 7 squared is 49, that's going to be less. But then 8 squared, 64, is going to be greater. So then I know, okay, the square root is between 7 and 8, which means when you floor it, it's going to hit 7. And that's why I subtract 1. And that should be easy enough to implement. But first I gotta freaking set everything here to 0, which is gonna be fun. I wish I knew how to do this faster, but I don't. Oh, I think there's a thing here. Oh, also, I think there's like ARG stuff. I don't really know. You can reload the level. Awesome. We're still on the correct... Okay. Sorry, I had the thing. So, here we are. Step 2. Obviously take an input. First thing you want to do is take an input. Sorry, I'm still eating. Next thing I want to do is have a for loop somehow. Right? So I'm gonna need to initialize a variable, and I'm gonna have to set it to 1 or 0 or something. So the question is, how do I do that? What food? Pot pie. I think what I do is, we're gonna use, I'll use this bottom variable as my, I'll use that as my, that's my input, right? This bottom, I don't know what to call it, but this, like, very bottom memory address, that's my input, so we're not gonna mess with that. The one above it is gonna be my next local variable. That's gonna be, yeah, that's gonna be my, oh my god, I can't freaking, like, think. That'll be my like I, right? Int I equals 0. So how do I set something to 0? I don't have anything on here that just like sets something to 0, right? I can set the value at that address to the accumulator value. So I can just kind of point in some random bit of memory that should never get set to a value. And that should always be 0. We can try that. I could multiply by 0, but I've learned that 0, 0 is actually counted as 100. But I could just do it twice, maybe? I don't know. I wish I was knowledgeable enough. Am I not explaining this well enough? Because that could also be the issue. I just bounce off this kind of thing? Fair enough. Okay, so I think the best way of doing it is probably to just load from a memory address that I could learn it, but I would need to be prepared to fail a lot. I guess. Although I don't know if there's all too much to learn. I think the instructions are pretty, like, clear with what they're set to do. I don't know. I guess it's more of a, like, practice thing. Okay. I think loading from a memory value that should always be 0 is probably my best bet. I could actually I could set it to 1. I'll just set this memory value down here. This is my 1. This is my constant 1. I should never change that ever. So we're gonna load that. That is the 2 lines. There we go. And we're doing this just in case there's some junk in the next, our actual variable, right? So our actual variable is the one right below that. And just in case there's some leftover junk from last time, I don't want to have to manually reset it. So I'm just going to make my code do it. So it's going to set it to 1. Oh, I should set this to testing. Yeah. So let's just double check this, right? Takes an input. I actually could have started from the next one over. Oh, I forgot to halt. Oh no. Okay. Bit of an idiot. Okay. Good thing there's a manual halt. So yeah, it set it to 1. That's good. And I can, oh, I didn't mean to do that. What I can do is I can come down here and I can set this to literally whatever. And then I can come up from here. I can run this. And it always sets it to 1. So that's good. That's what I want. Now, now this is where it gets weird. So I'm gonna want to compare. There's no reason to actually subtract, so I compare. Let me think about this. Wait, do I need a variable for this? I might be able to just load the value 1 into the accumulator, and I'll be fine. No, I do, because I need to square it. The screen is wrong. Oh, you're so right. Okay. So step 1 is going to be multiply this number with itself, right? So both the... Okay, I need to think about this. This is hard. Because I'm thinking about this for every loop, right? I'm gonna assume I put the correct numbers in each spot, right? Because what did I do? I load the number and then I set it, and then I set it to the other thing. So I have the numbers in the correct spot. So the next thing I need to do is multiply, right? I'm multiplying the number by itself. So I okay. This is weird. This is kind of weird. This one. And then we are using this one as our variable. So I'm multiplying the number by itself, right? And technically I'm doing that by multiplying the accumulator by the memory value, but the values are the same. I'm going to make sure the values are the same, so I'm just squaring the number. Then I compare. I compare to our inputs, which is all the way down here. If the input is greater if the input is greater, that means there's underflow, right? Then I need to do the loop again. If there's no underflow, then I need, if there's no underflow, then I need to load the value, subtract 1, which I still have 1, which is cool. Although I think there's a different subtraction. Yeah, there's just I could just subtract 1. Oh, this is weird. This is so weird. So, yeah, I'm comparing. If there's underflow, that means the squared number is less, so then I need to do the loop again. So I guess I'll jump if there's underflow. I'll figure out where this is going eventually. Jump if there's underflow. If not, I currently have the number squared in the accumulator. So what I need to do is load. Oh god. Not the button I meant to press. This is, or wait. This is load, right? Yes. I need to load the variable, this one, and then I need to subtract 1, which I don't know what the instruction is. Oh, that's Rave Aesthetics, sorry. Subtract, okay, it's 6, and then I'm subtracting 1, so I put 1 there. And then I output. But otherwise, if I don't want to output, I need to come down here. So this is where I should be jumping to. Is 10. I can't actually read these numbers, by the way. I'm just doing that off memory. I just remember that was 10. And here, what I need to do is, I need to load the accumulator value either way. So actually, I should swap these two instructions, but I'm not going to because that's probably more work at this point. But yeah, I load the thing, right? And then, in this case, I need to add 1 to it, and then I need to set it, and then I jump. So what's add? It's 5. Add 1 to it. And then I set this address. And then we go back to the top of the loop. And I think this works. I'm not sure. I'd have to think it through again. But it's like kinda it's very easy to get in the weeds here. Where are we? I need to jump, right. This is the jump, and then where am I jumping to? I'm jumping to the start of the loop, which is gonna be 4, I think. Yes. I could have just done a jump to the load instruction, whatever. Alright, we're gonna test it. Okay. Give me a small-ish number. And we'll see this thing in action and see if we do any of this right. I want to try and give a rundown of what's going on the screen again. But I don't know if I'd be able to do it justice. Casey, I need a number. It can be like 1 to 100, I guess. 4? Okay. So 4, it should give me 2, right? So this is 2. This is 4. So I'm gonna input 4. And we're gonna hope it gives me 2. So it's doing doohickey math. I forgot to halt. I forgot to halt. I forgot to halt. It's not gonna end. It's not gonna end, and it also outputted 1 at some point, which is both really bad. Okay. So we're gonna have to figure out what the heck just happened. Okay, that's awesome. Jump if there's underflow. Did it jump? Here, wait, let me check. Did it jump? Let me run this again real quick from here. So it should underflow, no? Okay, it didn't underflow. So something's... Didn't mean to do that. Why is it not underflowing? Because it's... I freaking bungled this and it didn't store the value. What are we doing? Okay. Yeah, so that's why I like having it on screen. I can just look at the bottom there and it literally just says 0. Like, oh, I wonder what happened. Okay. So that's bug number 1 fixed. Bug number 2, I forgot to freaking halt the program, which is kind of really bad. So what we're gonna do is, this is... What is this? Load 15? Okay. Or load 16. So we're gonna swap this with the top one. So this is jump if less than equal 10. This is load 16. I need to load the value either way, right? This is subtract 1. Yeah. Okay. So first, let's do... Set this to load 15, or 16. Then we'll do jump if not equal to So this is jump not equal to, and it's gonna jump to address 10, which is that one. Subtract, output, and now this is actually not jumping to 10. This is actually jumping to 11. Which I think that's... I've kind of lost track. Yeah, that's 11. And the reason is because this is now halt. This needs to be halt now. Which is the very last instruction, which makes it very convenient. So now... Yeah. This should all work. Pray... Hopefully. Pray tell. Not pray tell, that's the wrong. Just, we're praying. We're praying that it works. It did set the value. It set it to 2. It squared 2. And it output 1. Why did it output 1? Oh, I know why it output 1. Oh, that's really annoying. Okay. Oh, what do I do about that? What do I do about that? So, because it's a perfect square, when I subtract 4 from it, it doesn't underflow, it's exact. But because I'm trying to overshoot, it thinks it overshot, even though it just is exactly 4. So it doesn't... Okay. Crap. See, that's the really annoying thing about this, is that I'm gonna have to, like, move a bunch of my code. Okay. Okay. This multiplies by the register. This compares. If I could just add, like, a tiny bit in here that just subtracts 1 and then compares, that would be nice. And I kind of can. So what we're gonna do, and this is gonna look really stupid. So this compares to the bottom register. So instead of doing this comparison, we're just gonna jump to right underneath it. And we're gonna subtract 1. And then we're gonna compare. It was this one. And then we're gonna jump back up. It's like nothing ever happened. It's like nothing ever happened. Where's the this is the jump instructions, so I need to go to here, which is like 4 or something. I don't know. No, it's like 6. Okay, let's see if this works. Yeah! Good work, me. It has to go all the way down every single time. So now it's gonna overshoot. Right? Now it has 9 up there. So it outputs 2. Awesome! Okay. I'm gonna assume it worked. I'm gonna assume everything works perfectly, and I'm gonna run it. Okay, it gave me, I think that's either 9 or that's okay, 4. Okay, it doesn't work. So now it's 3, I think. And that's 9, I think. Okay, It's kind of hard for me to follow it, but it works. So like... One, two, three, four, five, six, seven, 8. Oh, that was 8. That was 8. That was the square root of 8. So it output 2. Yeah. I don't even know what number that is. That's 3 times 27 plus 2? 83? So it should output 10? This is gonna take a while. Oh wait, I can speed it up. Oh! Underflow! Underflow! Oh wait, wrong one. Oh wait, no, it's gonna keep underflowing. Right. Sorry, it underflows a lot. I'm waiting for it to not do that. Underflowed again. This is nerve-wracking. Oh my god. Oh, nope, it underflowed. I thought it was good. I thought it was good that time. Okay, wait. This should be the number. Oh, yes! Yes! That's 10 apparently. Oh wait, no, it should be, yeah, it should be 10. No, it should be 9. It should be 9. It should have output 9, I think. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm way off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's 12. Why is that 12? Oh, because it's 6 times 27, not 3, plus 2. So that's... I think I'm doing all of my math wrong. I think I'm doing it all wrong, actually. That's 6, right? That's 6... And it output 12? Okay, because it's 164, right? And that's, yeah, that's 12 point something, because 13 squared is 169. We're all good. I don't know why I'm doing the math that I just made a computer do. Like, I didn't... Let's just do it again. This one's gonna take even longer. Jesus. It's an even bigger number. I mean, you gotta check. I don't. It told me it's right. I don't even recognize that symbol. I don't know what number that is. Here, let's go find out. Oh, it's 21. Okay. So it's 7 times 27 plus 21. 289 minus 25, but then plus 21, so it's... Okay, this is gonna output like 16, I think. Ugh. That's like literally the biggest number it can output, bro. It's getting there. Oh, man. Oh, it worked! Yeah. Alright, one more. And then I have to debug it, which is gonna be so fun. It's 4 times 27. 108. So this is 110, so it should output 11. I don't know what number it's on. Oh, it's pretty close. Oh my god! The doohickey! Okay. Oh, it's doing bad things. Okay. My compare and my input are different now. Stop what you're doing. Okay. Okay. Is anything messed up? My 1 is fine. My 1 is fine. And I don't know what that's fine as well, I guess. I don't know why it's that number, but it's fine. I don't think anything got messed up. So I mean that's really easy to solve for, right? This should halt when I'm testing. It didn't do that. So I know it's swapped with something, and then the compare, or it shouldn't halt, but it should pause, right? It's waiting for my input. And the compare did that. So now we know these two are swapped. And we're gonna real quick do just a simple test. We'll do 2 tests. We'll do one with a square number and one with a non-square. I have no idea what this number is, and I kind of need to know what the number is. Let's do 8. So this should run 3 times. What does he even do? It's such a good thumbnail. It's so stupid. Okay, it output 2. That's good. That's what we want to see. Now we're gonna run it again. But I'm gonna put 16 here instead. And we should see 4. And if we don't see 4, we do some bug fixing. If not, then we should just be able to move on to the task 2. That's 4! Yeah! Yeah! This is awesome, is it not? Like, I don't know, this is so hype for me. Maybe that's crazy. 4! Yeah, like, I'm sorry. I'm getting hyped because I just made assembly code to calculate the square root of 16, bro. Like, oh, man. No, it's good. It's good. Please work. I actually have no idea what's going on right now. Like, I can understand kind of what's going on, right? Like, I can see the numbers changing in the way, like, I'd expect them to. Like, my temporary variable is being incremented correctly, right? My input is the input. But I have no idea if it's, like, working. You know what I mean? It should be outputting soon. Yeah. This time. It's gonna output. Yes! Yes! Oh my god! Okay. Okay, this is entirely new territory for me. So, this one is complicated. Greatest common divisor. Isn't that cool? Isn't that crazy? So it gives me two numbers between 1 and 1024, and I have to figure out the biggest number that both of them are divisible by. There's still two more. There's still three more. I have quite some time. And one of them, I have to find the next prime number. Like, oh my god. But it's gonna be fun. It's gonna be fun. It's just gonna take some time. I remember doing common divisor stuff and I wasn't good at it. That's interesting. I don't know why you would do that normally. Good thing is, good news, there's a very common algorithm for it. It's called Euclid's algorithm. Or Euclidean algorithm, something like that, right? And it's really, really easy. It's really, really easy. Step one, take in our inputs, right? Always take the inputs first. I don't know where I'll store them yet, but I'll store them somewhere probably. And here's the plan. Subtract the first one from the second one until we underflow. And then add it back, right? Basically just subtract it as many times as we can. And then, next step. We do it the other way. Until one of those numbers hits 0. And once one of those numbers hits 0, we output the other one. That's it. That's all you gotta do. It's genuinely a beautiful freaking algorithm. So what I can do is, I can store... We'll just pretend we're storing it somewhere for now. I don't know how long this is gonna be, but we'll pretend we're storing it somewhere. I need to find the subtract. Okay, it's 12. So we subtract, and this is gonna be the first number from the second. If it underflows, we need to check that, right? So we'll jump if underflow. But we're actually, this jump if underflow is pretty much just gonna be right before a different jumping instruction. So this is gonna jump quite literally just over the other jump instruction. So this goes back to the subtraction, right? This is gonna go back to the subtraction. Because it's just gonna keep subtracting, right? It's gonna keep subtracting until there's underflow. Then we add it back. We add it back one time so it doesn't actually underflow, right? Because basically underflow is like, oh, we've gone too far, let's take a step back. So we just add it back. And then, now that we've added it back, let me check something real quick. I don't know if adding sets the thing to 0. I need to go check if doing addition can also change the flags. Okay, it will. So, once I add, I can check if the number is 0, and then we return, right? Yeah. That's the plan. So we add from wherever we're storing it. I'm still not entirely sure, right? Jump if it's 0. Otherwise, we're gonna go into the other loop. So if it's not 0, what we do is we need to store whatever number we're left with somewhere. And then we need to load whatever number we have. Load is 3. We need to load whatever number is in the other variable, right? So we have 2 variables. This is just A and B, except we're kind of gonna mess with A and B. We don't really need to keep A and B. So we're gonna have like new A's and new B's. It's very confusing if you don't understand the algorithm, and I just don't really know how to explain the algorithm. But it's gonna work. So I store one, load the other one. And then we do the subtraction, but the other way. So it's literally just the same code. Jump if underflow, and that's gonna go 2 steps. And then the next instruction is going to be a normal jump to the subtraction. And then down here is going to be an add. And then we have, what was this one again? This was a jump if 0. This is actually going to be a different place. It's nice to see you did this stream and the genocide stream relatively quick after announcing you want to do it. Yeah, because that's just like, that's easy, you know? Jump if 0. So this one needs to output the second number, right? We have two different outputs, right? Because this one is if the first number hits 0, output. Or no, this is if the second. Yeah, no, this is if the second number hits 0, output the first. This is if the first number hits 0, output the second. So it's slightly different, and that's why there's 2 different loops here. Is because one is the second subtracting from the first, and the other is the first subtracting from the second. I pointed to them in the wrong order, but you get the idea. Now we're gonna store this in the original place we stored it. and then we're gonna load the other number, and then we're gonna jump back up. And this is gonna jump all the way to this subtraction, I believe. No. This is the subtraction. So we jump to instruction 3. And now down here we can have our outputs. So this should load. Whatever the other number is, and then output. Oh no, we'll make this a jump, I think. We'll make this a jump 2 spaces down. Because we'll make this a different load, right? And then we make this the output, and then this is the halt. So now our memory, we'll put it here. We'll put this is memory address 1, and then this is memory address 2. Easy enough, right? So now let's think this through. Let's think through everything we have. we need to basically trace our code and put the correct variables in the correct places. So this is variable 1. We are... Oh wait, sorry, I just realized I put these as set commands. They should be load commands. There we go. So this is our variable 1, right? Cool. This is our second input. That's just gonna stay there. We are subtracting from variable 1 in this case, over and over. This jumps, yep, this is all good. This adds, this should also add from variable 1. Jump, this is jump if it's 0, so we'll take this to our first loading, which is gonna be here. So that's kind of looks like a H kind of thing. This one. So now, if it's 0, we want to take variable 2. Or no, we want to take variable 1. We want to take variable 1. And we want to, output it, right? Yeah. And I don't think I need variable 2 stored here just yet. Yeah, I don't. So this load down here should be variable 1. And then this is, we store variable 1. Or no, this is store in variable 2, right? Because variable 1 should stay unchanged, and then we load variable 2. Then we're gonna subtract from variable 2 over and over. Add from variable 2. Jump to a different part in the code. So this is here, right? And this should be loading from variable 2. That should be simple enough. So that's gonna be, okay, it's there. And that's here. There we go. Now this should be storing in variable 1 and loading variable 1. And I think that's good? I don't know. I have no idea if any of this code is right. Which is scary. That's a little scary. But we're gonna test it. Okay, input. Give me two numbers, Casey. Two numbers. Any two numbers. It should be fine. $18 and $56. Okay. I think that's 18. Let me go check. I know this is a little annoying. I apologize. That is 18. Okay. So this is 18. So we're gonna input 18. And 56 is gonna be, okay. 56, so 27 times 2 is 54. So it's gonna be, 2, 2 in base 27. What is the... I mean, we have all this time to figure out what the GCD of these two... I forgot to halt. I forgot to add a halt command. So we're oh, no, I do have a halt command. Okay. I'm actually good. I'm actually good at this. Sometimes I just don't trust myself. So 22. That's 18. And that's 56. Okay, now we have all this time to figure out what the GCD of those two numbers is. 56 is 4 times 14. And 18 is... Oh, it ended. Okay, it got to 2 already. Oh my god, that was fast! No, that just makes sense, because it only has to do, like, 3 subtractions, and then it's just there. Oh my god! Jesus! I mean, that's insane, no? What the heck? I mean, this, like, it's just... You'd never expect it to be that fast. But no, the GCD of 18 and 56 is just 2, I think. Yeah, because, I mean, 18 times 3... 56 minus 3 times 18 is 2. And if you can get to a number, like that, the GCD has to be divisible by that number. And obviously 2 is prime. Alright. Let's try 18 and 57, why not? Their GCD should be a little more complicated, I believe. Nope, it's gonna be exactly the same, actually. It's gonna be 3 subtractions. Let's try 18 and 63, maybe? Nope, that's still 3 subtractions, I think. Give me some bigger numbers. Let's try some bigger numbers. Although it's gonna take me a second to calculate them in base 27. Actually, okay, something I want to try personally. These aren't big numbers, but I just really want to see, like, how it handles this. We're gonna put in, 13. And then 7. So I don't know what it's gonna do here. It output wrong, so that's not good. It just output 7, I think. Did I accidentally put in 14? I'm pretty sure I put in. Okay, let's go check. No, that's 13. That's 13, and that's 7. So I need to figure out what has just gone wrong. So I subtract 13 from 7. That's immediately gonna go bad, right? So then it immediately is just like, okay, add that back. I get 7. It's not gonna be 0. So then we put 7 into the storage. That's good. Subtract 7. Yep, that's good. It shouldn't underflow. It should give me 6. Thirteen's prime, so it shouldn't do anything funky. So then, yeah, it should underflow again. It should add it back, but it shouldn't get me 0. It should give me 1 at the end of the day. I think. Yeah, because it should be 7 minus 6. So I need to figure out what's gone wrong. I guess I'll just run it again, and we'll see what happens. I'll have to watch a little closer. That's 13. That's 7. So it underflows immediately. And then it doesn't load... Okay, wait. No, that's confusing, no? Let's double check my code. So when it tries to do the other way around, it saves... okay. It adds it back, jumps if it's not 0, or jumps if it's 0. It saves whatever number is there, which is what it should do. And then loads it for no reason. I actually don't know why I did that. Am I saving it to the wrong place? It should save from 2. I need to load 1. That's what's going on. That's why it's dumb. I'm loading 1. Yeah. Okay. And that goes for down here as well. I should be loading 2. Okay. So there we go. We've bug fixed. Oh, that is hard to wrap your head around. Jesus. No, I mean, it makes sense. Why would you save and load the same thing? I mean, I understood what I was trying to do, which is put 1 in storage and then pull out the other one. But instead, I just put 1 in storage and then kept it on there, which makes no sense. And that's why it's outputting 7, because it's just like, okay, I got the 7. GCD of 7 and 7 is, in fact, 7. There's 13. There's 7. So this should be done after 2 runs, because 7 minus 6 is 1. Please output 1. It didn't output 1. I don't know what it's doing. Oh wait, no, it's fine. It's fine. Oh my god, I don't know why I was so worried. I forgot. Okay, it has to do 0 minus 1. Is like, that's a thing that has to happen. And I forgot about that. So I was like, I saw 1 in the freaking accumulator, and I was like, you got the 1. You figured it out. But it wasn't there. Like, it hadn't gotten there logically yet. Sorry, I just emoted IRL. You couldn't see it, but like I was so elated there. It's working! What emote did I hit? I just like, I basically did absolute cinema. Okay, test run, test run. Please, please work, please work. It's so scary. I don't know what the numbers are. I can't see the numbers anymore because I'm storing them way down. It worked. It worked. I don't know what happened, but it worked. It found the GCD. I don't even know what freaking number that is. That's such a big number, no? What the heck? Run it again! Run it back! Run it back! Yes! Oh my god, oh my god. This is making me so giddy. That's an F, what the frick? One of the characters is an F? I mean, there's also an S, I guess. And a U. This one, I honestly think this one's easier than the square root. Maybe I'm crazy for that, but like, I feel like it's easier. There's a really... Oh my god, wait. There's something really interesting about this. So, one of these is next prime. In theory, I could do, like, GCD stuff, I think. With every prime up to, like, the square root... What's the square root of 1,000? Up to 31. So that's, like, not bad at all, right? I mean, that's, like... I don't know, that might take a while still. But if the GCD of... like, how many primes are there? Primes less than 31. I could take the product of all of these numbers. That's a pretty big product. But yeah, I could take the product of all these numbers. If the GCD of this number and whatever number I find is 1, then it has to be prime. Alright, anyways, back to running the code. I don't know what any of these numbers are. That's the beauty of it, is that I don't have to understand, like, the numbers. Because I understand the code. That was a quick one, Jesus. Okay. So here's the plan. I don't know what 2 instructions have been swapped, and some of them can destroy data, right? Okay, step 1, go into testing mode. Step 2, let's try halting first. Let's see if the halt is broken. Halt is not broken. Let's see if do nothing. Nope, do nothing is still do nothing. Another good one to test. So I'm gonna go back to this. I'm gonna see which ones of these can destroy data. And that's what I'm gonna focus on. So we have set, right? Set can destroy data. So we're gonna wanna be careful in case set is the one that's broken, right? Same with uset, if that's... I mean, I don't have a uset in my code, so that should be fine. If set isn't swapped, I should be able to just run the code and see what happens. Otherwise, I'm going to have to be I'm gonna have to do some different sort of diagnostic. So what we're gonna do is we're gonna do this set, and we'll just do the address right above it. And that should change values, right? And then we'll halt. So that's taking an input. So yeah, that's not what you want to see. So my set value and take input have been swapped. By the way, this is a good way of like testing your knowledge, but at the same time, you can definitely like copy someone's code and then just have a basic understanding of like what else is going on. So, I need to change every set to a 1, every input to a 4. I think that's all of them. I think I've gotten all of them. So we should just be good. We should, I mean, let's just send it, right? Let's just send it. I have faith in myself that I won't accidentally explode my code. This runs much more efficiently than my freaking square root, by the way. Worth noting. Yes! Yes! We're on to the next stage. Okay, here we are. So what is this one? This one is ternary representation. And I have, n is less than 2047. What is 3 to the 7th? It's 2187. So every number is gonna be small enough. So, how do I do this one? Pretty sure it's actually just really easy. So we're gonna have a few variables. I think I can just put them down here. Actually, maybe not. Let's call this is our variable space. We're gonna start with 1. And then we're gonna do 3. You're gonna notice a pattern. This is 9. This is 27. This is, screen wrong. God dang it. This is 81. This is 243. And this is, 729. And those are our variables. At least those are our constants. We are gonna have, maybe a local variable up here. And maybe a different constant up here. I don't know. But these are our powers of 3. And what I'm gonna do is, we're actually gonna start from the bottom. I'm gonna reverse the order of these, just to make my life a little easier. So this is actually gonna be 729, and so on. You can see, I'll show it off once I actually have this correct. Wait, you're staying, I think. So you can see, if you look at this, this top register, or whatever it's called right here, this one, as I move down, it just shifts each thing to the right, right? That's all that's all it's doing. So what I'm gonna do is obviously start by taking an input. And then we subtract. I'm gonna try and make this as simplified as possible. But not simplified, but compact, I guess, which is gonna make it a little more complicated. Step 1, we're gonna have a variable set to 1 here. Actually, no, we're not gonna set it to 1. We're gonna set it to 28, because that's where our variable space starts down here, or our constant space starts here. Oh, it starts at 27, sorry. It's 0 indexed. So that's our other constant. We're going to load that. And then we are going to set our variable to that. And here's where our loop starts. Oh, actually, I forgot to store my thing. I forgot to store the other variable we have. So I'm going to do that first, because that's kind of important. That'll just go up there. Usually I have it at the bottom, but we'll just put it there for convenience, because I already wrote other stuff. Load. Load U. Store it in U. I'm using my right hand, and I should stop. Okay. So the idea is, right? I subtract what happened to my hand, just like over just RSI kind of stuff. I think I can subtract from an address, right? Yeah. Can I... Okay, I can't subtract... Okay, this is gonna be interesting. This is gonna be a little weird. But I think it's still better. Actually, I have a hilarious idea. Okay. Really funny idea. I'll have to figure it out. But this is our subtraction. This is our subtraction command. And then we're gonna... This is our subtraction. If it underflows, then we need to add it back and then return 1. Otherwise, we can subtract again. and then we can add it back and return. Actually, wait, no. If it doesn't work the first time, we return 0. So maybe I should be... this is so weird because I have to keep track of so many things. Okay. Let me think about this. I have the power of 3 I'm actually subtracting, right? I have the power of 3 I'm actually subtracting. I have... Okay, this is what we'll do. We'll have another variable. I need to remember where I'm putting all my variables. This one. I have to set it to 0 every time. Crap. Okay. So I can't load it just... I can't load this one just yet. Because I need to load... I need to load from somewhere that'll be 0. This is so annoying. Okay. Let's just scrap it all for now. We have our constant space. We don't need to scrap it all. I'm overreacting a little bit. We know, for example, this is never gonna be... Well, the number before this, I guess. That should always be 0. We'll make sure that's always 0. Oh, wait. Yeah, I guess that's fine. Now we load the number. What am I doing? Oh my god. Okay, this is actually confusing me. I need to take a step back. Okay. We're subtracting every power of 2, one by one. So... we have the... not powers of 2, powers of 3. If it immediately underflows, it's a 0. If it can be subtracted twice, and then it underflows, it's a 1. If it can be subtracted 3 times, it's a... 2. And then we move on to the next one. So, we have all our powers of 2. We have the place we're storing the number. And we have... no, I keep saying 2. We have a way of... we have a pointer to the numbers. Or a pointer to the powers of 2. And then we also need a variable tracking the number, the current number. So, okay. That's what we have here. So we're gonna be loading. So we load this, and then we need to store that to not there. I don't know why it's... should be loaded to there, right? Trevor's going insane because he was seeing the translation. What? That's crazy. And then we load. So yeah, I'm just setting all my variables right now. Yeah, so I load the first. I load that. Store it there. Load that. And then I need to store it. I guess I'll pick the 3 lines. I don't know. I might get a little tight with the code. I might have to move that. Wait, I don't even need this constant. I have this constant already. That's just in space, that one. So that's something to think about. I'll think about it later though. So now all of my things should be initialized, right? I should have my pointer pointing in the right spot. I should have my thing set to 0. And I have my input also stored. So now what I do is I actually subtract, I think. So that's subtract. And I want to subtract the value at the address 10, right? Then if it underflows, if it doesn't underflow, I need to add 1 to my counter that I have. Okay, I think it's going to be easier if I just subtract it 3 times. I don't know. I can't tell which one would be easier. Because I jump if it underflows, right? Because if it... Oh my god, this is so annoying. Okay, new change of plans. We're gonna do a comparison. If it underflows, we move on. If not, we're gonna add 1 to our counter. This is so annoying. Oh my god. Okay. Oh, this is so annoying. Okay. Okay. Compare. If it underflows, we jump and we return 0. Okay. If not, we subtract. And then we compare again? Well, no, okay, I have my loop here, though. That's just a good loop. The thing is, it's like, I do it 3 times, though. For no reason. Okay, wait, we're just gonna... Okay, we're gonna... I don't need to compare. We just subtract. We just subtract. Subtract, check if it underflows. Subtract, check if it underflows. Subtract. Check if it underflows. Well, no. If it goes through 2 subtractions, the third one will definitely underflow. I don't even need to do this one, right? This one doesn't need to happen. This one I can just load the value to, I think. So I can just if I have a constant 2, let's go there real quick. Let's just add another value to the constants table. So right after 1, we'll just make this 2, because why not? So this is just load it was that load 2 and then output it. So that's that. Now these jumps are gonna have to load 1 and 0 respectively. I'm gonna change this to that, just for consistency. I actually don't think I need that anymore, because I'm not using this variable anymore. So we can move quite a bit of this up, which I'm going to do, because it's pretty repetitive, actually. Oh, actually, maybe I don't want to do that. Okay, we're gonna leave this empty space just in case this code breaks down a little bit, because I can absolutely see that happening. It doesn't hurt to leave just a bit of empty space. So subtract, jump, subtract, jump, subtract, jump. Or subtract, or no, it doesn't subtract. It loads 2, and then it outputs 2. The other ones, they need to add back. You need to add the value back, right? Well, I guess they can, yeah. We'll do it this way. Add the value back. Output 1. Oh, it's so hard to get wrap my head around. Jesus. Okay. Output 1. You still didn't change the screen? God dang it. I'm sorry, I'm bad at that. Load. So, 1 is gonna be 1, 2, 3, 4, 5, 6. Yes, this is 1. And then I output that. Or no, I should start with 0, which is gonna be 8. Output. And then this one's gonna be, or I don't know where this one has to like jump somewhere. So we'll leave a jump here. This really gets in the weeds. Jeez. Okay. So this can't be my constant anymore, and I definitely can't use 5 as my pointer. So, oh, this also has to jump. Jesus. Okay. So all of this is just gone. You're gonna have to try. I also want to watch Dylan freaking play Celeste. God dang it. Okay. I have a new plan. So, the ultimate idea here is that, basically, these subtractions, I'm gonna replace each one of these subtractions, these 2 subtractions, with the with the actual, value I'm trying to subtract. So right now, they're set to default to 729, but then I'm gonna set them, I just increment this, right? I just do this, and now they're set to the next value, and I can do that over and over. I don't actually need a pointer to do that. I don't actually need a pointer. I just need the default value of this, which is that, obviously. So instead of loading this, what I can do is I'm gonna go down here into my constants again. I have so many constants. We're gonna set this to subtract 1, 0, right? Trevor's ending soon. Nice. So now, this is crazy. This is crazy. He says to himself. We go to 1, 9 is the, yeah. So we're gonna load 1, 9, and we're gonna load that into, and this is what's crazy about it, right? I'm setting the instructions that I am about to run. I am actively changing the code that I am running. That's the plan here. Is to actively change the code. And this is why I think this is crazy, right? So I steal the instruction. I'm loading the instruction from memory, right? This is the instruction I'm looking at, right? This is the subtract. I'm loading that to the pointer. And then I am setting these 2 instructions to that. I can start these off at 0, right? I can start these off at absolute gibberish. It doesn't matter, because they should be overwritten. Then, I load... I don't even know what that's loading. That's probably vestigial. I can probably get rid of that. Oh wait, no, I know what this is. Sorry, this is my funny gibberish. Because it sets the subtraction, right? Compares if it's less than 0. Then it does, and if it's underflow, then we'll have a case, right? Then it does the subtraction. What is this? This is assembly code. I wish you were here for the start of it, because it's like I'm really in the weeds right now. So here's the documentation. Here's how everything works. Basically, it all the accumulator is the big thing. The thing on the right is the memory, but it's also like the instructions, right? The memory and the instructions are the same place. And it basically reads from memory and it goes, okay, I'm gonna do whatever it tells me to do. Whatever the memory's telling me to do, I'm just gonna do that. Based off of, down here. All of this stuff, right? These are all the possible instructions. And I have to code it. Flashbang on the remote OLED, sorry. I have to code these different things. Right? So I've done the first two. Or the first three, sorry, it's freaking 0 indexed. I'm currently on task 3, where I need to find the ternary representation of a number. And that's what I'm working on. So, okay. Jump if underflow. If not, we're gonna load the value 2 and output the value 2. And then this is gonna be a jump. This has to be a jump instruction to who knows where. Just yet. This is gonna be output 0, I think. And that should be 0. Oh wait, sorry. That should be 0. Let's just double check. So this, yep, that's 0. And then we want it to jump, right? And we'll figure out where it jumps. Oh, I didn't output. I'm stupid. I'm so stupid. Okay. Output, and then jump. Nope. And then this is gonna be load, this is gonna be load the number 1, outputs, and jump, and these jump instructions are all gonna go to the same place. Actually, this one doesn't have to jump because it's at the bottom, so that means it doesn't need to jump, right? You can just do the next bit of code. So, the idea is, I load the value from this code, right? I load, this value, which is, it says 6 currently, I think. So I load that into the pointer. I'm loading the instruction into my freaking accumulator right now. I'm going to add 1, which I forget what the thing is for that. It's 11. Oh wait, no, I need to add n, which is 5. I add 1. And then and this is where it gets freaking weird. I'm going to set I'm going to set the instructions to that number. So this is actively rewriting the code as it runs. And then we jump all the way back up to it. The big issue currently is that this doesn't know when to stop, and I need it to know when to stop. So what I'm gonna have to do is I'm gonna have to let's find this. So this is where it should stop, right? If it gets to this number, it should stop. So what I'm gonna do is I'm gonna have this down here. That's my stop. This is gonna be weird. I'm gonna subtract yeah, I'm gonna subtract from that address. What address was it again? 110. 110. 10 is a digit. This is probably really confusing, and I apologize. If it's exactly 0, and then we'll put the normal jump here. But if it's exactly 0, we're gonna jump past that. And we're gonna halt. But otherwise, we're gonna jump back into the code. Okay, this is kind of a lot. I'm not sure if it's gonna work. So, okay, we take the number in. We put it in storage somewhere. That storage space is being used. We'll fix that. We load a number. Or no, I think that's our starting constant. Yeah, that's our starting. Here, let's just test this real quick. So this should set our instructions properly. Yep, you can see it sets the instructions properly. So that's what that does. We'll figure out this. I didn't switch. God dang it. Okay. Input, load it to, or set some place in memory to it. We'll figure this out later. Load our initial instruction. Set the first 2 instructions. This is just do nothing for now. Then we subtract. If it's less than 0, we jump, which I haven't set the jump yet. I guess I'll do that real quick. It should just jump to 13, I believe. Where it loads 0, it outputs, and then jumps. Yep. And then subtract again. If it's underflows, it goes to 16. Cool. Then if those 2 work, then we don't need to subtract again. We know it's a 2. We load 2, we output it, and then we jump to same place everywhere else is jumping. Where this loads the instruction from the top, adds 1 to it, and then sets the 2 instructions up there to the same thing. This subtracts what, if we get to the past everything, this subtracts what would be the technically like the wrong instruction, right? This is checking if we've hit the wrong instruction. If it's 0, we jump out. If not, we jump back into the code, but I've actually forgotten to add it back, so that would be disastrous. Oh wait, no it wouldn't. I don't need to add it back. What am I saying? Oh, I've forgotten to load. Yeah, this subtraction is fine, but this halt does need to be down one more instruction. And this jump needs to be down one instruction as well. Because I've forgotten to actually load the freaking number again. I also forgot to freaking set it again. Dude, hop on the incomprehensible mechanism. I'm already on it. Don't worry about it. That's what I've been done. Okay, so I actually need everything here to be one instruction lower. Which is really annoying. Because once I output, I need to set something. And then I can load. Okay. So that's awesome. We can just move this halt somewhere else. So that's good. But yeah, I need to load wherever I'm using the memory. I don't even know. I'll just put it in some like I'll put it in like 2.0 or something. Put it in 2.0, do all the math, output, jump. I should really figure out where are these jumping to again? They're jumping to here. It's this weird H thing. This one. That's 18, I think. So yeah, I need to load, or I need to set the value again. Then I need to load, what is this? 5 is add n. I need to load the instruction. I need to add 1 to the register. And then I do the setting, subtract, jump, and then jump back up. So let's actually do this bottom to top because it's easier that way. This is incorrect actually. Wherever this is jumping is wrong, so I should figure out where I'm actually jumping to. Sure. We'll go to freaking, I don't know, 1S, whatever the number S is. This is a subtraction, so it's do. This one, technically, I don't actually need to swap them around. I can just put 6 here, but I'm going to because I like the order of it. And in theory, this should all work now. What if Dylan's waiting on me? Is he? Oh, I'm sorry if he is. Or did he just start stream and that's what you're saying? So I actually had space, it seems, to put the halt there. Oh wait, no, I don't. I don't, because I almost forgot. This jump needs to be lower. Because I need to load the number. Where's the number stored? In 20. Okay. I think it works. I don't even know. I don't know what just I don't know what's going on anymore. Honestly, I have no idea. This one's really freaking hard. Oh crap. Okay, it was wrong, and I don't like that. I meant to run it as a test. Okay, I mean, let's start with like... Start with like 1, right? I don't like what I'm looking at. None of those are zeros. How do I know if it's a new output? Alright, we're gonna stop it because it seems to be completely wrong. Okay, so I have the subtraction, right? I think it's subtraction. Dylan doesn't believe this is GD. Pause real quick. Okay. Subtraction. Yeah, this is subtraction. Okay. I'm pretty sure I'm subtracting from the right place. I wish there was a slow-mo version. Like, I wish I could slow it down. So it subtracts if it underflows. Oh, if it underflows, I'm never adding it back. I'm not adding it back. And that's bad. Oh, you freaking idiot. Oh my god. Where's it even jumping to? Right here. Okay. That should be 0. I don't add it back. I don't add it back. Frick! How do I resolve that? Ooh. Ooh. That pisses me off. Okay. Okay, good news is I should have an empty space. I don't have empty space. Every single space here is filled up. God, what do I do? Okay. No, it's fine. It's fine. It's fine. I can figure this out. So, this jump goes to, here, right? That's good. What I can do is, this is also a jump command. right? This jumps to here. I can just make it jump somewhere else. Or not. Oh, do I have the... What did I do? I paused. Sorry, was it off screen? I don't know what's going on. I'm coding and it's kind of... A lot of my brain power is being put in this right now. Because this one is... Oh my god. Okay. I need to add it back. I need to add the number back. The issue is, if I'm adding the number back, that also means I need to add the instruction. Subtract, jump. Subtract, jump. So what I can do is, I can subtract, so I have the number, it's stored here, right? Subtract, jump, if it underflows. But the same number is still stored, right? So if I store the number again here, all's well. Same if I store it after here. And then I shouldn't have to store it here. So maybe I can... Oh, it's so difficult. Maybe I have the space. Let's try it. So these loads should go one sooner. Or maybe not that one. But yeah, this should be the subtract. This should be the jump. Wherever it freaking goes now. I mean, who knows? But we'll put it to the same spot for now. And then underneath, we need a store. Or it's a set command. So if it's fine, we'll set it. We'll set it in stone, right? We'll say this is our number now. Then we subtract. So that one stays. So the first one changes, the second one stays. Then we jump if it's bad. But if it's good, we store it again. And then we can output 2 and everything. So I need... Oh, I need to move down pretty much everything past this jump command. Technically, any of this can happen. Oh wait, no, because this loads too, so it needs to, all of this needs to move down. Because I need to store it and then load 2. Okay. So this store command is stupid and dumb, and I need everything above it to move down. So that's 3, that's 1. This is actually this now, I think. No. That's just 1. So yeah, my jump commands are also outdated because they should be 1 lower now. Is there anywhere else that jumps differently? This will probably jump differently as well. Oh god, this is certainly a time, no? Don't you just love debugging and then having to rewrite like incredible amounts of your code? It's okay though, because we're gonna get through it. So this one, right. I subtract, I check if it's less than 0, and then this is where I store it. And that's at 2, 0. So now I need to make sure my jump commands are correct, which they probably won't be. So this is 2. That's fine. This is 1, I believe. No, this is 0, I think. Yeah, this is 0. So 3 lines. That's gonna be this one. Okay. It just moves down 1. I think that goes for this one as well. Yes. Loads 1. Okay. Then I load the instruction, add 1 to it, and then but actually this instruction is wrong now because it's moved up. And then what is this? Why is this here? Oh, that's our compare. Because it subtracts from here, it compares, and then it jumps to that, and that's what halts. Is this not meant to be a halt? Did I forget to halt? Okay. I want to say every bug is fixed now. I don't like what it's doing. Okay, it outputs 0. Wait, why did it output 0? Why is it starting with 0 now? That's not good. I don't like what this is looking like. I don't understand it though, is the issue. So it starts with 1, subtracts a bunch. Okay. This is so hard to bug fix. Jesus. Oh my god. This is so hard to bug fix. Oh man, okay. So it starts by... right. This is my memory. This is my 2-0, and then it resets instructions 5 and 8 to 1-0, which is, yeah, subtract the biggest number. Right, so that should all be working. And then it subtracts. This is a subtraction, right? It subtracts from the biggest number. And then shouldn't it jump underflow? Oh, I see the issue, I think. It's reading and it's setting them. But then it's not pulling the number back. Okay. That's my issue. Okay. So it's setting the instructions, but then it never actually okay. That's fine. God. Yeah, it's never pulling the number back, which is obviously an issue. Why is this setting it? This should be loading it, no. So I can actually just jump to here. So it looks kind of like a grappling hook. So it sets the 2. This subtraction is unnecessary, but it's just like I just have the code already, so I might as well. And then it jumps to not the first instruction, so this is also wrong. There we go. So yeah, we'll jump to the grappling hook, I guess. So instead of doing all this, we're gonna set this to nothing. I way overshot. I actually want to look for the grappling hook, and then this is a jump instruction. And then this is nothing. So it pulls out 1 again, and then output's 0. Does some BS. See, I can't tell if it's a new output is the issue. But it's jumping. It's jumping to 0 every time, I think. And then it pulls out the 1 again. Oh god, what just happened? Did it just screw up my code? I don't know what just happened. No, that's fine. That's fine. That's fine. That's fine. Okay. I'm so confused. I'm just gonna freaking change the number I'm inputting here to 1. And then I want 2, 3. So that should be 21. Which is this. Or not, I guess it's not 2, 3. It's 2... What is it? I guess it should be 2, 0, right? So that's 18. I think I should have passed it. 18. 1, 2, 0. Or wait, is this... This is base 27. What's 27 squared? Okay. Oh, this is so confusing. One, 2, 0, I think is what I have. Wait, I'm supposed to have 7 trits, right? 27. Oh, because each one of these... Okay. So it's 1... Then I need 2, 0, 1. Which is 19. And then I need that again. Okay. So this should output 1. Okay, there's 1. Should do 2 subtractions. Okay, output's 2. Then it should fail, right? Output's 0. Okay. Should output 1. Okay. Output's 2. Okay. And then it should output 0. Okay. And then it should see that it's 0 and it should halt, but it's not doing that. It output another 1. Oh wait, no, yeah, it's 1, 2, 0, 1, 2, 0, 1. That was right. That was right. That was right. I think that was it. I think that just worked. I'm actually not sure. I mean, that felt right, right? I mean, it did the exact number I was looking for. 1, 2, 0, 1, 2, 0, 1. I'm so confused. Oh my god, this is so confusing. Okay, let's try like once. Give me a number where every single digit is different. Give me a number, like, write it in tertiary. Just a string of 7 zeros, 1s, and 2s. Starting with not 1, by the way, because it ended on a 1, so I need it to not be starting with a 1. No, I need 7 1s and 2s. Different, all different. First one can't be a 1. Zeros, 1s, and 2s. I'm literally just. I need a. You get the idea. No, it can't have 7s. I need 7 digits. 7 digits. And it can start with a 0. Seven digits, all different. It's dual stairs. Sorry. It's probably confusing. Dylan's probably on 8C right now and I'm missing it, but it's because I'm coding. No, they need to be okay. It's fine. It's fine. I'll figure it out. They need to be different though. Like they can't be adjacent numbers can't be different because I need to watch it update. Like 210120 or something. What did I just say? I don't even know what I just said. Pepsi milk. Should I try Pepsi milk? Sorry, I'm looking at Trevor's chat. Okay, I still need a string of digits. I'll figure it out. What did I say? I said like 2. Okay, I mean this first one's easy. 2. I don't know. We'll go 2101. So 101 is gonna be 10. 2101 210, which is 21. Which is this trident thing. 2101 210. 2101 210. Okay, watch the output. Should go through everything. In output 2. 2. That's our first number. Then it should be a 1. That's a 1. Then it should be a 0. There's a 0. There's our 0. Then it should be a 1 again. There it is. There's the 1. And then it's 210. Bring it home. Bring it home. There's a 2. That's a 2. Then it's a 1. And then it's a 0. Bring it home. Halt. Halt after this. It's over. Yes! Yes! Oh my god! Yes, bro! Oh my god! Oh my god! Oh my god! Oh my god! Bro! That's crazy, no? Isn't that crazy? Oh my god! Oh, it's so much harder when you can't freaking copy paste, bro. Okay, okay, run it. Run it, we're good. Come on, come on. Big money, big money. That's 1100 1 or 10. Oh my god, 1100 012, which is kind of hard to follow. There's the 0. There's the next 0. And then this one's also gonna be a 0. So it's gonna jump. Yep, output 0, I think. And then this one's also a 0. So it jumps down immediately. And then this next one is a 1. So it's gonna do a little bit. There's the 1. And then this should be a 2. And then it should halt. And then it should halt. Oh my god! Oh my god! Oh man! I don't know if my solution is at all good here. It feels kind of overcomplicated. I mean, I'm literally changing the instructions of the code as it's being run, which just feels like kind of overkill. But I think this is maybe, I don't know, I think it's still pretty compact. Like I feel like this is a very good solution still. I use so many constants, it's hilarious. I have a constant for every power of 3, 2, 0, and the initial instruction, and the final instruction. That's so many constants. It's okay, because I'm gonna use the same architecture for freaking primality test, where I'm gonna store every single prime 31 or less, and then I'm gonna GCD test it. I'm gonna GCD test every single one. I don't know. I don't know how I'm gonna do the next prime algorithm, because I don't want it to take forever. Although GCD testing isn't bad at all. Alright, just one more, and then I have to do some bug testing, which is gonna be kind of scary. Yeah, no, the issue with the next prime algorithm is honestly like, how do I do that efficiently? You know what I mean? Do I like make the sieve of Eratosthenes? And then I just find whichever number is, you know, like... Okay, that's still halt. Let's test set. Ah, crap. Okay. My freaking pointer is set to 0 right now. Let's add n. It's 5, so we'll just try add 5. Set this, and then alt. No, wait. Add somewhere that's also out of memory, but distinct, just in case. So those are both fine. Okay. So it's not setting. It's not setting, that's the issue. It's not addition, that's the issue. Check input, I guess? Okay, so input has been swapped with something, and I don't know what. But what I can do is I can just go through every single one of these until it halts. Because we know it's not anything damaging, so we should just be fine, I think. It's okay, it's low. So that was easy enough. So What is this? What is this doing here? What? Oh, sorry. Right, that's my constant. So this is load. And then every time I have a load in here, this needs to be set to every 2 needs to be set to a 1. Or it's not load, sorry, it's output. I believe that's every output in the code. Run it real quick. I don't actually care about what this is outputting as long as the code is functioning. And then I don't actually know what this number is. It's 1, 2, so apparently it's 1, 2, 0. Yeah, that is 15, so that checks out. 0, 1, 0, 0, 1, 2, 0. That is correct. So we're good to go. I have faith in my code. Yes! Oh my god, that took so long. That took so long. Jesus. Okay, we're on the final one. We're at the end. I just have to figure out how to find the next prime number in a sequence. So the question is, what's the easiest way of doing this? How do I find the next prime number in a sequence? Without it taking freaking forever. I'm not sure if I know the answer is the issue. I don't know a clever way of doing this. I think what I want to do is a sieve of some sort. So I have to figure out how to do a sieve. And I only need the primes up to 31, right? So the way so here's the idea. If a number isn't divisible by the square root, if a number isn't divisible by some number less than the square root, less than or equal to the square root of that number, it has to be prime, right? Because otherwise, it would have to have two factors greater than its square root, which would just be greater than the number itself. It doesn't make sense. So, the square root... I know my range is 100 to 1,000. So I know the square root of 1,000 is 31, right? So I only need to check prime numbers up to 31. Anything else, then it should just be prime, right? So what I can do is... I can take... however many numbers I have. I don't know what what is the largest prime gap? Let's find okay, I'm confused. Never mind. It's like 20, I think. Okay. Yeah, here's the idea. I think. Is that I take the number. Well, I have to sieve. I'm trying to figure out how to, like, make a sieving algorithm, basically. Screen? I know. I'm not doing anything on the screen. I'm just thinking. I mean, I think I just have to make a sieve of some sort. I just don't I don't see how else I would make this run at a reasonable time. Unless, what is the largest prime gap? Well, it's 22, but I'd have to check divisibility. I'd have to check so much divisibility. Like, that just can't work. So... how do I want to do this? Genuinely, how do I want to do this? Okay, I have an idea. I have an idea. I don't know if it's good, but I can reserve pretty much the first bit of this to a sieve, right? The first like 27 memory slots to a sieve. Then what I'm gonna do is I take the input, right? Or where do I want the sieve to happen? I guess I want it to happen up top. No, I don't think I want it to happen up top. It'll just happen in memories. No, I do want it to happen up top. Sorry, I'm being indecisive. Well, how? How do I make it work up top? How do I find freaking primes, man? Oh my god! In a timely manner. It has to be a sieve. It has to be a sieve. There's just no other way of doing it. I mean, I could just do like a really fancy search, right? I can check for a prime. I can check if it's prime. I can check for what it is mod 6. Get it to some number, some good number mod 6. And then add 1 in 5 over and over, check primality. I don't know, checking primality just sounds like such a waste of time. My plan is... Can I take the address? I don't have the... I have no way of taking the actual address of where I am. Crap, how do I make a sieve? I need to have like an array or something. Yeah, I have to have an array, and then I like set all the values to 0, and then... Jump not 0. Okay. Okay, I have an idea. It's really stupid, but I have an idea. I just have to think about if it works or not. Okay, so I'm gonna have to set every... Right, okay, okay. No, I have an idea. Alright, here we go. So, we're gonna take an input. Then, here's the fun bit. We are going to... Screen this time. Yeah, no, you're right. We're gonna do a for loop. So I need... Okay, actually, we don't need this to start down here. I think it's kind of more annoying if it starts down here. We'll start up top. Take an input. We're gonna need a for loop. Okay, we'll... No, this is fine. What is this? This level is called DETERNARY. but this kind of code is assembly, basically, except, like, really weird looking. You've probably heard of assembly. A lot of people like saying Roller Coaster Simulator was coded in assembly. So yeah, I need a for loop, so I need to load a value, set some, so I need a constant, set some memory value to that. Well, actually, sorry, I need to load this into memory somewhere. Oh, I have an idea. Okay. We're gonna load this into, let's put it kind of far down. Let's put it in like 4, 0. So 4 is gonna be, that's gonna be my array. 4, 0 is my array. And we're gonna put this, we're gonna add, this is gonna be add 27, or it's actually 26. Sorry, I've baited you all. Add 26. We're gonna store that in 426. Now this is where my for loop begins. So what we're gonna do is we are going to add 1. Store that in for 1, right? Then we need to load that, add 1, store that, and then load okay, we're gonna subtract. No, I can't subtract. Well, I want to load my value back, but it's kind of hard to do that. So instead we're going to increment the other variable as well. Oh wait, no, I don't have... Oh my god, if I do this for loop, it's going to, like, suck. Crap. It's probably more space efficient than trying to load... Okay. Let me think about this. Right. Load into 9. The issue is this isn't... I haven't, I don't have any way of initializing this currently. Oh, this is so annoying, isn't it? Yeah, it's ASM technically. God, man. I mean, could I just... Okay, we're gonna scrap this, I think. Actually, I can just restart. Take an input. I need to store it somewhere. Now, the thing is, right? I need to make an array of values. Wait, no, that's bad, isn't it? Yeah, it is bad. Okay. How do I want to do this? Oh, I see. I'm not gonna store this in 4.0. I don't know where I'll store it yet. We'll have a variable. We'll set to 0, right? Jeez. We'll have a variable we'll set to 0. Or we'll keep it 0. We'll load it here. And then we will put it into our actual our local variable. Then we're gonna do a for loop. So what this is gonna do is it's going to set we're gonna set oh, it still kind of runs into the same issues. Okay. So I need to initialize this as well, which is gonna be weird. So I initialize our thing here. Our variable. But then I also need to initialize our initial instruction because I'm going into memory. And that's what's so annoying, is that I'm going into memory. I do have a use set, which kind of does what I want, but I'm not gonna use it because it's just more confusing, I think, if I do that. So what I'm trying to get right now is an array from 1 to 27 that I don't have to generate myself. So that generates our initial instruction. Now we set that then we add 1 to our... No, this is just so confusing. I don't know what I'm doing. I need to think this through. Instead of just doing code, I need to really think this through. Instead of loading data from where that address was pointing at, put the accumulator value there. So I can load a value into the accumulator and then put it in a position. Okay. That's good. So maybe I can get away with having just one... Yeah, I can. Okay, okay. I get it now. I think. Yeah, I do. Okay, okay. So we're still gonna have a variable initialized to 0, right? That goes here. Then, what we do is we add a different variable, which is going to be our uset command. This is what uset is, by the way. Instead of loading data from where the address... Basically, I'm putting the accumulator value at whatever address I'm pointing at, I think, here. Like, I can take a variable. Oh wait, I see it now. Okay, okay. No, I'm understanding. Okay. So I need to start at 40 instead of 0. I start at 40. I do a uset. To my variable. Oh, wait, no. Oh, crap. Okay. No, this is much easier if I... No, it's fine, I think. It's fine, I just have to subtract 40 from my thing, which is gonna be awkward, but it'll be fine. Okay, we'll try that. So yeah, I add a certain number which gets me my command that I need, right? And then I set wait, no, this makes no sense. Okay, okay. Sorry. My variable starts at 40. Or I guess it can start at 0, right? We'll start it at 0. We'll have a different variable that I jump to. Yeah. It starts at 0. I add n 40. I set a different address to that. Then I uset, or I subtract 40, sorry. Is that my subtract? Yeah. And then I do my uset. And that's gonna point to whatever memory address is up there. And then that should work. And then I load my original variable, add 1, and then set it. So let's just put, this value doesn't matter just yet. this value has to be 0, so we'll put it, or wait, whoops, let me, like, halt. Or no, wait. Right, I set the value, and then I want to actually subtract, 27 or 26. If it's 0, jump 0 is 16. I want to jump to halt, which I will put right there. Otherwise, we jump back up to instruction 4. Okay. So I load, so I guess this will go to 15. This will go to 16. This will go to 17. This will go to 17. This will go to 16. 16. That's all good. What is this doing? Hello? Is this supposed to jump? Oh, that's risky. I shouldn't have that. I'm not sure if this is working. Oh, okay. I see. So, this should absolutely not be a freaking subtract, and I'm stupid for making it a subtract because I didn't add back. So instead this should compare with, I don't know, this number here. So yeah, that's probably smarter. So this is me trying to set up my array. So we'll let this run. I probably won't let it run all. Actually, you know, we'll just let it run all the way through. So there's gonna be a bunch of junk around this area, I think. Oh, there isn't. Okay. And then... oh, here's all the junk. Here's all the junk. Welcome to my junk pit. I don't know how long this ran for, but we're gonna try and reset all of this just because... okay, it didn't run for all that long. And then down here should be an array of values. And it ends prematurely, but that's okay. Sorry for not chatting that much, that's alright. So yeah, this is an array of values. It starts from 0 and it should get up to 26, but it actually only gets up to 25. It shouldn't matter, but I mean, I'll fix it anyways. So yeah, that's the first bit of my code. It generates an array of values. So that's all fine and dandy. The next thing I need to do is find the remainder of every value greater than 31. Is sieving, is that overkill? Am I overkill? Like, am I doing overkill stuff? I can't tell. I can't tell. Is there some better way of doing it? Maybe there is. Yeah, I mean there is. There probably is. I'm gonna restart. So, okay. I think I'm doing it overkill, right? What I can really do is take the input, store the input. We'll figure out where eventually. And I can divide by 2. Multiply by 2. If they're the same number, if I can compare and there's 0, it's divisible by 2. If not, I move on to 3, right? And then I move on to 5, 7, every prime. If it's not divisible by anything up to 31, it's prime and I return it. Otherwise, add 1 to the number. This is going to take a good while to run, but it should also end pretty quickly. And it's much less complicated. So, let's check real quick. We have multiply and divide by actual values, right? So I can hard code these values. How many primes are there from 2 to 31? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's not much code at all. So what we're gonna do is we're going to it's stored somewhere, right? So that's good. We're gonna multiply by 2. Or sorry, divide by 2. Then we're gonna multiply by 2. And then we're gonna compare. Is that my compare? No, it's not. I know what my compare looks like. It looks like that. And we're gonna compare to whatever memory address I put it in. And then I jump if 0. Which is jump Z is gonna be 16. So that's gonna be our wacky one that I thought I had earlier. And jump if 0 is just gonna, I'm just gonna add 1 to the value. And then that's it, I think. Then I load. Then I reload the value, right? Now there might be a better way of doing this. There might be a bit of a fancier way. Instead of me having to hard code every single one of these, I might be able to be just a little fancier. Because I can read... Can you load? Yeah. Okay. Okay, let's be a little fancier. Let's be just a little fancier, okay? So, we're gonna have a for loop. Sort of. Actually, no. Do I want to do this? Yeah, because look at how many instructions I'd have to rewrite over and over. That's really boring. So... we're gonna have 2 local variables. One's a pointer to my... to my list of prime numbers, which I'm gonna have. The other one is gonna be a is gonna store the actual current prime number. So step 1 is to load the initial value of my pointer wherever I have that stored. Then I have to set it, right? I have to set my pointer. Then I do a U load. I'm on the wrong screen, sorry. And that'll load the first prime number, which should be 2. Then we do the division. So I need to scroll down. I have to share it to scroll down for some reason. So then we multiply. Which looks like this. Or sorry, divide first. So it's like this. Then we multiply. Then we compare. Then we jump if 0. Then If not, we add 1. So we have to load our pointer value, add 1 to it, and then set it. Oh, I forgot to... Oh, after the U load, I forgot to set. God dang it. Okay. I have to move everything down. Good thing is, I kind of don't have most of the things figured out just yet, so it's actually less hassle than it sounds like, because I just don't have the memory addresses figured out yet. So before the U load, or after the U load, I think, I have to set my other thing to it. Yes. Okay. So right, jump if it's 0, because if it's divisible. No, I need to jump if it's not 0, actually. No, I jump if it's divisible. And that'll go, so this should just be a jump. Like a normal jump. Back up to the U load. Yes. Otherwise, this is where the other jump command goes. And that's 14. This one is going to load our initial value, add 1, and then store it. And then it's gonna, I guess it jumps to here, right? Because it's gonna reset everything. So it jumps to instruction 2. So now, so this is, okay, this is our full code. Except, oh my god, I'm an idiot. Crap. Okay. I'm gonna have to do something extra. So, this, if this instruction gets past, how many primes? 11? If it gets to 12, it should just return whatever value I have. And there's some other stuff I'm missing. Okay. So this loads, right, this loads the number from memory. Or no, this loads a different thing. Okay. So I have a couple things I'm missing here that are definitely bugs. So I add 1. I load, or I save that to thing, but I actually, before jumping, I need to do a couple other things. So it's good I figured that out. So first of all, I need to compare. And this is going to be some constant somewhere that I set to 12. If it is 0, jump if 0, and this will be my full, like, output. Otherwise, this is... Right, this is setting up for the next number. So I need to load... You load into memory. Oh, I have to do it up there. Oh, God. Okay. I have to bump everything down. Or just do a jump, but I'm just gonna bump everything down. It's not that much of a hassle. It just takes a second. So this jump instruction is probably wrong now. So I just won't do it yet. So this is where I need my load. I need to load the initial number again. Compare. Jump if 0. If not, we load the variable, add 1 to it, set it, put it back, compare it to 12. If it is 12, we jump out. If not, we jump back. Yeah. Okay. We jump back to instruction 4, where we're loading the next number. Now this is if it is divisible. So we load the number. Add 1 to it. Save it in memory, and then jump to instruction 2, where we're initializing the loop again. So this should be all of the code, I think. Well, wait. Okay, now if I jump and it's 12, now I need to load... I need to load the number again. And then I just output it, and then I halt. This should be all of the code. This should be everything. Why is this so short? Okay. So now that we have all of the code figured out, now we can worry about where all of our stuff goes. So let's put the number in 26. I like that. So we're saving it to 26 here. We gotta load it from 26 here. And now we gotta load it from 26 here. We're also saving it to 26 here. And we are loading it from 26 here. This jump is if we've done the loop 12 times. So this should go to our output, which is going to be the hook. Now this one is if it's not divisible. Or this one is if it is divisible, right? Because dividing and multiplying gives you the same number, which means it divided cleanly. So this goes to our add 1, which is going to be the this one. So this is our number. I would love for this to just be our set of primes. I think it can be. Well, actually, I'm not sure. We still need to store the constant for the start of this somewhere. And we also need to store the number 12. And is that it? Oh, this should be, sorry, this comparison is also with 26. Yeah, I think that's it. So we can store our constants here, right? And we have just enough space to make this work. So this is just 1, 0 for the first one. And now what memory space is this? This is kind of a, okay. It's like 1 with a line through it. It's probably near the end. Yep. So we load that. Oh, I don't have space for my pointer. Okay, we'll just have the constant 12 somewhere else. It is a constant. It doesn't matter. So I'll put it right after. Yeah. So there's our pointer. So then we load from the pointer, obviously. Okay, no, we don't have space. So we'll have the constant 12 somewhere else. We'll have it like right under. Actually, okay, we'll change this, I think. Yeah, this will just start our constants off, and then I'll put our special constants a little later, I guess. This will just be a variable. This is what'll hold the prime number, the current prime number. This is our pointer to the prime number. This is the actual value of the prime number. This is our actual number. Some of this surely makes sense. Clueless, clueless. So this is some constant. I don't know yet. I also put it in wrong, so whatever. I also put this one in wrong. So we'll save it to there, right? We load it, and then we save that into here. And now we are going to multiply by this, because this is our current prime number. Then this is going to be loading the pointer. Add 1 to the pointer. Save it to the pointer location. Compare with it's supposed to be 12, but I guess it's our number plus 12. Yeah. Compare if it's 0 and jump to outputting. Yes. God, this is hard. Okay, let's start putting in primes. This is our first prime. It's 2. Then it's 3. 5. 7. 11. 13. 17. 19. then is 23. Let's see what number 23 is real quick. 23 is this wacky thing. And I'm gonna real quick check I have the rest of them correct. 19, that's good. 17's good. 13's good. 7's good. And then I know 5, 3, 2. Okay. After 23 is actually pretty far. It's 29. Which is 1, 2. And then it's 31. Which is 1, 4. So that's all our primes. So after this, we can put in our constant for the end, which is just itself, actually. So that value just stores itself, which is really cool. And then also our value for the initial address, which is going to be, yeah, 10. So this should load not from 10, but 113? No, 112. 112. This is the wrong number. There we go. And then this comparison down here should be comparing to 111. Yes. And in theory, this just works. But I'm not sure. Oh, wait, there's an issue. There's an issue. Oh my god. Oh, I didn't think about this. If a number is less than... Okay. No, I can fix this really easily. Instead of going through every single prime, I have to check... Instead of checking, like, is this the end of the primes, I have to check, is this number, is this number less than the square root of whatever prime I'm using? So, down here, instead of comparing to 12, so I load it, I add 1, the pointer. Oh, that's a lot of code I'm gonna have to rewrite. God. Okay. No, it's fine. Because what I can do is I can move it all. Okay. This is fine. It's just gonna be a bit crappy. So, yeah, here I have to, so I'm adding 1 to the pointer. I have to compare the prime squared with whatever. Because, like, wait, no. Wait, no. It's a prime number. It's not going to be divisible by anything. What am I saying? It doesn't matter. It shouldn't matter. It's going to be pretty redundant, but it shouldn't matter. Yeah, okay. No, I'm fine. Sorry, I was worrying about nothing. Don't even worry about what I'm saying. I think we're just good. I'm gonna try it with 3. So 3 isn't divisible by 2. So it should throw a fit about that. But then 3... Oh wait, 3 is divisible by 3, so it's not gonna work. Sorry, I still need a sufficiently large number. We'll go with sufficiently large as in less than the primes I have. So that's gonna be this is 27, 28, 29, 30, 31, 32, 33, 37 should be good. And this should run for a while, but it should return 37, I think. I can't see the numbers, which pisses me off, but I think it's working. Yeah, you can see it's returning numbers that are very close, but slightly wrong. And then it's incrementing the counter. So that's 7. It's 8. Okay. It returned 37. Okay, okay, okay. Oh my god. Oh my god. Oh my god! So let's try, this is 37. Let's try 33. So 33 should fail, right? And then it should hit 34, which should also fail. 35 should fail, 36 should fail, 37 should pass. So it should go through all of those. This is gonna run for quite some time. But man, is it gonna be so awesome if this works. Okay. Okay, it just moved on to the next number. It immediately failed, so it's moving on to the next number. This is 35, so this should run 3 times. So this is the second time around. It's not divisible by 3, so this is 5. Now it's like, hey, this is the number. So then it's like, okay, give me a different number. This is 36. 36 is divisible by 2, right? It's gonna immediately go down. Boom. Give me another number. 37. And now it's just gonna be here for a while, right? Because it has to go through every single prime, because every single prime less than 32. So it's gonna be here for quite some time. But it's because I know what the range is that I can do this. Because I've just hard coded the first 12 or 11 primes. This has to be maybe the cleanest code I've written. But it's probably because it has a lot of ROM. Technically, it's not actually ROM because you can't write to it, but you really shouldn't. It returned 37. Oh my god! Oh, Dylan's getting really close to clearing HC. I'm kind of really sad that I'm not there. But I've also just, like, been coding out of my mind right now. Like, look at this. This is... So these are variables, right? This is 26... Or no, sorry. This is 26. Or this is the 27th line, right? This is 24 lines of code. This is 24 lines of code! And it's finding prime numbers. I mean, ignore that there's 3 variables, and then there's, like, 13 constants. There's like 13 constants, but it's like 20 lines of assembly plus some constants, and it's finding prime numbers. Like, what? All right, let's see how long this takes to run. I really hope this works. I really hope this works. I don't know what number that is. That's like 270 something, man. That's a big number. I want to say that's 19. Yeah, 270. That's 289. So it's 291 prime. Let's pull out a list of primes. What's the next prime? It's 293. So we should see a little like wheel circle thing. So we're getting there. It's at 291 right now. I don't know what 291 is divisible by, but it could be a while. Okay, 291 is actually divisible by 3 and I'm stupid. So this is gonna take no time at all. It's at 292. And there it is. That was 293 for a second. Yep. So now it's gonna go through everything. You'll notice the top, the accumulator will actually go to the smallest, or the largest number less than the number we have. That is still divisible by whatever prime is trying to check. Which is really interesting. I don't know if that makes sense, but like, for example, if you plug in 293 here, it'll spit out 292 at some point, because 292 is divisible by 2, and it's the closest you can get to 293 while still being divisible by 2. Then it spit out 291 at some point, 292 again, probably. Or not 292, because it wouldn't do 4, it would do 5, so it would hit 290 at some point. Oh my god, and there it is, there's 293 as an output. I'm giddy. I'm genuinely like, oh, this has to be one of the coolest things that I've ever done in Geometry Dash. Run it again. Okay, what is that number? That's 22. 22 times 27. Plus 7 is 601. I'm pretty sure that's 7. Here, let's pull this up real quick. While this is running, it doesn't really matter. Yeah, it is 7. So it's 601. That's the number it gave me, is 601. The nearest prime to 601 is actually 601, so it should just return itself. This should spit out 601. Which is gonna look like that, right? It's gonna look like that F weird thing. So it's at 1.9 right now. I hope my play-by-play is like helpful, by the way. It's at 110, so it's almost through all the primes. It has 2 more left to check. Or no, that was it. Okay, sorry. I was wrong. Yeah. Oh man. Okay. What is this one? That's 272. So the next prime is 277. So 273. It's gonna get straight through 273. I don't know what the divisibility of 274 is. It's still on 273, I think. No, now it's 274. 274 is prime. No wait, that's easy as well. 4, 5, 6 easy. 277? I don't know what divides 277. Oh wait, no, that's the prime. Okay, no, so these are all easy. These are all easy. It's not giving me anything too bad yet. Nothing divisible by like 19 or something, right? That would suck. And that's just how it's gonna be, right? Most numbers are gonna be divisible by the first few primes. So there it is, that's 277. It's being actively checked right now. I'm purely just reading the top display, by the way. I'm just interpreting the numbers. And I just, like, I know my code well enough to understand. Like, that's the, it's going to the 4th prime, right? Whenever you see a 1 up there, that generally means it's, the number next to it is whatever prime it's checking. So that's 1/6, so it's checking the 6th prime. It's like, oh, it doesn't work. Here's prime number 7. great. I'm not sure why it's... I get scared because it seems like it only does 10 primes, but I thought I had 11. No, okay, wait, there's only 10. I have up to 31. Sorry, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Have I missed a prime in here? Oh my god, I might have missed a prime. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. Oh, it's 0 indexed. Guys, I'm so dumb. It's 0 indexed. I was so worried because I was hitting 10 and then stopping. It's because it's 0 indexed. Jesus. Freaking heart attack. Like, programmer forgets his code is 0 indexed. Freaking idiot. 0 indexed, it means it starts at 0. When I'm at 10, it's not the 10th prime number because it starts at 0. The 0th prime number is 2 in this case. So the 10th prime number is technically the 11th. It's just offset, right? I'm yapping, but you get the point. I see 10 and I'm like, I thought there were 11 primes, and it's because one of them is under 0. One of them is the 0. And I'm just dumb, and I forgot that in my own code. Okay, whatever. I mean, it's working. That's all that matters, is that it's freaking working, and I'm honestly, like, over the moon. I am over the moon. I can't be, you know, all that frustrated when my code is working. That's 22 times 27 plus 9. $603. So, I mean, we've already done 603. We went through 603. No, we didn't. No, we didn't, because we hit 601 and that was it. But it's just 4, 5, 6, and those are all easy, right? I mean, I've just gotten hit with absolutely nothing difficult. I could have coded in, like, the first 3 primes, and I would have actually done fine. Now, I could just eat my words. But it's on the 5th prime. I'm saying the correct number now. I mean, I did code for the worst case scenario, right? I had never tested the worst case scenario, but I did code for it. So I'm happy to say this should just work. For any number less than 1,000 or so, but it's also really easy to expand this. If you get the first few primes up to whatever square root you want, you can very easily just expand this. If you fail, do you restart the entire level? I think you just reset the single task. I'm not actually sure, and I do not want to find out. Okay, down here we're gonna do some testing. We are on the final stretch. This is it afterwards. Halt is correct. Halt is the same. We have some BS in the accumulator, so we can test our setting. We'll just set the instruction directly above. That's input again. Okay. We got really lucky. It's swap 4 and 1 again. And that should just be it. Oh my god, I'm gonna be done. I'm gonna be freaking done, man. Every 1, swap it with a 4. So this is 1, 2, 3, 4. Every 4, swap it with a 1. I use 4 quite a bit in my code because that's kind of just how memory works. You have to load it and set it very often. Make sure none of those were any specific variables. They weren't, because that's these 3 slots. This is the home stretch. Yeah, this is it. This is quite literally like the last thing. Let's just test our code. Make sure it's all working. Start with a very small number. Or actually, it doesn't really matter, right? Let's do something fun. What's a fun one? What's a pretty big gap in the primes? 548. So that's 20 plus 8. So this should run for quite some time. I have no idea what kind of divisibility it's gonna run into, but this is just for fun. And it should output 557, by the way. But just, it's quite a ways from here. So 8 is obvious, 549 is pretty obvious, that's divisible by 3. 550, obvious. 551, I don't know. .551 is divisible by 19, so if you see 551, I don't know what 11 is, unfortunately. I guess I'll look on the left. Okay, I know what 11 is now. We're actually on it. So this one's gonna take a bit. This one's gonna go through the loops. But it should eventually flag as correct, and then it'll continue on. So it's not this one. I don't know which prime is 19. Probably it's somewhere in the halfway. We're on the 8th prime. There it is. There's 19. So, yeah, now this is 552. 553, I don't know. .553 is divisible by 7, so that's another tricky one. 4, 5, 6 are all easy. So this is 555 currently. So it'll run around twice. Oh, there it is already. Okay. 556, this is gonna immediately be like, okay, well, here's the number. Bonk. Get me out of here. And then this is 557, so this should be the final run around. I'm so much more competent in this than I thought I would be by the end of it. You know what I mean? Like I can read the top register. I can interpret my code, or I can interpret it in the context of my code. Because I'm just looking for very specific values. After this, I get to watch Dylan actually freaking play like 8C or Farewell. I don't know where he is. I'm like kind of sad I missed him discovering hypers, honestly. Main West with assembly skin. Absolutely not. This took freaking forever, bro. I'm gonna have to go back in Dylan's stream and see his reaction to hypers. I'm pretty sure he already knew what they were, but like, I still want to see. What the frick is this solve of this room? Hello? That's 557. We're good. This is it. This should be it. This should be the end of DETERNARY. You thought it wasn't base game? Okay, so he was just shocked about it. He wasn't. I'm assuming he wasn't surprised or anything. He was just like, "Oh wow, that's kind of cool." I guess surprise is still applicable, but he wasn't like, "No way." He was surprised. Yeah. All right, I'm sending it. What number did it give me? I don't know what that is. 17 times 27? That's such a big number. That's such a big number. I don't know what 22 squared is. Oh, it's 242. Minus 20. Oh wait, no, it's 484. Minus 25 is 459. 459. Yep. And then plus 23. I was just doing that because I wanted to. So this is, it gave me 482. So I'm looking for 487. So that should be a different digit, actually, yeah. Instead of S, it's gonna hit me with, I don't remember what's after S. That. 18 times 27. And I'm looking for 49? No, 487. So I'm right here. I just need a 1. Yeah, this is the number. This is it. Like, oh my god. I can't believe it. I can't believe it. I'm pretty sure I overcomplicated my freaking base 3 representation, by the way, after doing this code. Like, I'm pretty sure I could have just done division and been fine. I mean, this, like, prime number algorithm and my GCD code have to be, like, just so awesome, honestly. Like, I've never coded in assembly. I've debugged assembly. Or, not even debugged, really. Oh my god, there it is. That was it. Oh my god. Yes! What do you mean there's coins? Oh my god, that's gotta be part of the freaking like ARG or whatever. Oh, it took me an hour just to do the primes, I think. Oh my god, it's been 4.5 hours. It's been 4.5 hours. Jesus. Oh my god. Oh my god. Oh, jeez. Alright. Alright. Oh, man. I can't believe that. I mean, that was just fun. Like, I genuinely had a lot of fun. I don't know if it came across. I think it did, because I've just been tweaking this entire stream. Remember to rate it? What do you mean? It's rated. Here, I'll give it a thumbs up. Oh, that's the first thumbs up I've ever given. It's Extreme Demon. It better stay Extreme Demon, or else I'm pissed. Yeah, no, that was awesome. Oh, it's 2 a.m. It's 2 a.m. Oh my god. I was so locked in. I was so locked in. I didn't realize it was 2 a.m. When did that happen? What? Oh my god. Oh my god. Yeah, I wish I could explain what was going on just like a little better. But I don't know. I'm just happy I got it done. I've wanted to do this for quite some time. I just want to look at this again. I just want to like really take it in, you know? Prime counting machine. Obviously, I kind of cheesed it a little bit with the restrictions, but I mean, that's why they're there, right? Let's maybe a little more into this. Right, there's a modded DETERNARY, so that's scary. This is probably what the coins relate to, so that's fine. Yeah, maximum. I mean, maximum was so long ago that took me like 10 minutes. Square root was easy. GCD was really, honestly, GCD was pretty free. Ternary took me freaking forever to figure out like how I wanted to do it, and Next Prime was also really tricky because I was like, I just didn't know the approach. I mean, that's really what gets you, right? Is like, how do I approach this? Well, yeah, by the way, I'm using a browser source here. That's why I'm not signed in. I just think it's way safer, and I think I'm gonna continue like Why do I not use browser sources for this kind of stuff? Put me on Bingo Sync browser source, you know? It's just so much better. I might never use a freaking window capture again. I don't know. Well, that's not true. Like, my freaking Celeste keyboard is a window capture. Okay, well, I don't really have all that much to say left. That was a lot of fun. It took forever. It was pretty tough to think through, right? Because I'm using freaking assembly. I mean, jeez. I have so much more respect for, like, anyone who codes in assembly after this. By the way, like, it's tough. I mean, obviously, it's, like, way better if you have basic text editing shortcuts, right? Like, I don't have copy-paste. I literally can't read what I'm doing, right? Like, if you just have, like, subtract instead of freaking, like, oh, the number 12. Like, it's gonna be easier. But it's, like, it's hard. It's still hard because you have to think through, like, you have to manually keep track of your variables, right? It's not just like, oh, I'll just name a variable. No, you have to, like, you have to say, hey, I'm gonna put this variable in this area, and then I'm just gonna have to remember, like, that's where it goes every time. That's that variable, right? And I didn't even really get into pointers and stuff. I mean, I did have 2 pointers, right? That did happen. Although at one point I wasn't really using pointers, I was just actually modifying the code, which is, like, really dumb. I should have used pointers, or honestly, I shouldn't have done it that way at all, because there was a way easier way of doing it with basic division. But it's, you know, it's fine. We got there in the end, and it was just fun. That's another platformer extreme down. I mean, I think it should count as an extreme. It's obviously, like, a completely... Oh, that's my 50th. Oh my god. That's obviously completely different to any other extreme, really ever. Oh, I have 4 friend requests. I should check those. But it's, like... It's hard, right? You have to freaking... You have to do code. You have to code. It's not easy. Oh man, I'm just happy. I'm just happy. Alright, I'm gonna go watch Dylan freaking actually play Celeste, because that's kind of a thing I like doing. Please tell me he hasn't done 8C yet. I mean, I would be very proud of him if he did, but I would be very sad that I missed it. Okay, he hasn't. Alright, stream over. Bye, stream. Bye-bye. Thank you, Casey, for being here the whole time. Watching me, like, code incomprehensibly. I mean, like, I'm honestly surprised you could sit through this. Like, it's probably absolute nonsense. Alright, nothing else to say. Bye-bye. Bye. That doesn't count as Markiplier. I wasn't thinking of Markipliering there. That was just me, like, saying bye in the same way he does, by pure coincidence. Like, I'm not even kidding. That was me saying bye. Like, sorry, this is a tangent now. I didn't Markiplier. That was me saying bye with the same cadence that Markiplier happens to also use. Like, unironically. Okay. That's enough. Bye. Get out of here.